So here's problem number 1. I'll go through each one of these in a separate video. So number 1 is a factor problem. And so I've written the steps for factoring here. Step 1 is look for a GCF. After you've done GCF, see if you got 2 terms, 3 terms, or 4 terms that you're dealing with. If you got 2 terms, we have a factoring method, and so on and so forth. Okay, you can write those on your formula sheet, or you can memorize these things. And then when you get done after doing that factoring, you always check to see if you can factor some more. So let's go to number 1 here. I'll check for a GCF, and when I check for a GCF, I check for 2 things. I first look through to see if there's a number that each one is divisible by, but since my lead coefficient is 1, I can't take a number out. And then I check for a GCF for the variables as well. They've got x's in the first term, the second term, but not the third term, so I have no GCF that I can take out. Then I go, okay, you got 3 terms here. Now I've got 3 terms, so we got 2 factoring methods. This is the factoring method where a is 1, which is our easy one. So it's just x and x. And then remember, what goes here is r and s, and r times s. When your a value is 1, r times s has to end up equaling your c value. So in this case, our r times s has to equal, there it is, there's c, 6. So it could be 1 times 6 or 2 times 3. And how do you decide which one it is? You focus on the b value, the coefficient of the x term. b is negative 5, and r plus s have to add up to your b value, negative 5. Okay, so in this case, we can use either 1 and 6 or 2 and 3. But since they have to add up to negative 5, one of them's got to be negative. But since they multiply to 6, both of them are going to have to be negative. You can't have just one negative and still multiply to a positive 6. So in this case, it forces us to choose the 2 and the 3, but both of them would have to be negative. So when you add them, they add to negative 5, but when you multiply them, they multiply to 6. Now, once we get down to these binomials that are linear, we are done factoring, because you can't factor anything unless it has at least an x squared in it. And so we're done. That's it. Number 1 is complete.